Hey class, so we've been talking about transformations. The focus for today is mainly rotation. Rotation is when a movement of a figure by turning it around a fixed point. Okay, this fixed point is what we're going to be focusing on how we turn. Rotation. Three things that we really need to know when we're being asked to do a rotation is the degree of rotation. Okay. Are we going 90 degrees? In this case, we could be looking at clockwise or counterclockwise. That is the second thing we need to focus on, which is the direction. Some people get confused when I say right or left, but a clock moves in the right direction, the hands. Okay, counterclockwise is going backwards. Okay, that's another way to look at it. And then we talked about clockwise and counter for the direction of rotation. And the last thing is the center of rotation. The ones we're going to see today, the center of rotation might be at the origin, in this case in the middle, or it could be on one point. For example, here, as you can see, the rotation off of point A. Find the coordinates of the vertices of each figure after the given transformation. So not only are we going to rotate it, we're also going to write the coordinates of the new rotation. In this case, it says rotation of 180 degrees about the origin. So the origin is going to be my starting point, and the 180 is my degree of rotation. But notice it doesn't say the direction. And that's because if I started here and I went 180, it's right in the middle. Same thing, if I go the opposite way, I will still meet at the same location. So it doesn't matter if you go right or left. We're going to go ahead and take our patty paper and mark our original point of H. And I'm going to create my perpendicular lines in the middle. So this works as a checker of every time I turn 90 degrees. Since two lines that intersect, perpendicular lines, they're going to create 90 degrees. So each turn is 90 degrees. I'm going to put my point on the origin, which is my starting point, and I'm going to go till it's even. Notice how it lines up evenly. That's one turn, which is 90. And I'm going to go one more time and match up evenly. My paper is sliding, so I want to make sure it's right there. Okay, let's go ahead and let me show you one more time. I have it matched up, and one turn is 90, and the next turn is 180. And I'm going to look at right where it landed and put my H prime. You have to put prime because that is the new transformed point. So if there's no numbers on the line, X to the right is positive, to the left is negative, and on the Y, the top is positive and the bottom is negative. I'm going to start from the origin and I'm going to count. Since I'm going left on the X, it's negative. 1, 2, 3. So this one is negative 3. On the Y, I'm going to count. 1, 2, 3, 4. Positive 4. So this is how we write the coordinate after the given transformation. I'm going to do one more, but a little bit quicker now that you know how to do it. I still have my perpendicular line since we're going about the origin. It's going to work. And in this case, we're going to rotate 90 degrees counterclockwise. Counterclockwise means left. It's if the clock would go backwards, it would go left. And the origin is going to be my starting point. So I'm going to write my original point of C, put my pencil at my origin, and I'm going to go left. One full turn till it matches up again. And that's where my point lands. One more time. I'm going to go one full turn, and I can see where my point lands, move my paper, and put prime C. I got to do my X and Y coordinate. So from the origin, I go right 1, 2. Right 2 is positive, and you can always check your reference book. Down 1, since I went down, it's negative. And that is how we write the coordinate after the given transformation. I'm going to do one more video, and that will be on how to move a figure. But this is, remember, you got to look for the three things, which is the degree of rotation, the direction of rotation, and the center of rotation.